What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are now beginning a run of YouTube videos for the SAT. And the reason being is that the March SAT is right around the corner. It's less than 2 weeks away. And by the way, I'm scheduled and signed up to take the March SAT myself. So I'll be taking it in person for real, just like everybody else. And we'll be doing a live score reveal and all that good stuff. So you can look forward to that as that video kind of gets ready and we take the test. But meanwhile, what I'm planning to do for you guys here is I want to do a video every day leading up to this test starting today. So for everybody who's cramming and studying and really going strong, we're going to be doing one video every day. Now, what that's going to be exactly yet, we still haven't figured it out, whether it's going to be one of these videos. And if you guys have feedback and you're like, hey, we'd love to just see you go through all of the practice tests one more time, or all of the officially released tests, or this and that. Like, if you guys have suggestions on what you'd like to see, let me know. In addition, we'll also be doing some other deeper dives into specific strategies and tips of particular types of questions. So we've got some things in the works, but I'd love your feedback to see what you want. But I'll be on here every day for the next week and a half, basically, until the test. What's up, Mohammed? I'm good, man. How are you? SAT is on Wednesday. All right. Well, I hope you're using the channel and looking at a lot of the videos. What's up, everybody? Sahith, Nuftug, Renaro, great to see you. Great to see, or Rorona, whatever that. I'm not sure if I'm saying that pronunciation is correct, so I apologize. Okay, here we go. Thank you, man. Appreciate it, guys. Appreciate the support. Okay, without further ado, we're going to jump into the mix and we're going to take another one of these mini time sections. This is a calculator section, so of course, I'm going to pull up a calculator here on the left. And we're going to jump right into it. Now, of course, when I take these things, these mini tests, I'm seeing them for the first time in real time. So we're going to see what's what, and we're just going to go with the flow. And I'm going to solve and problem solve in real time. So official practice test. Okay, that's what you want to see, Anne-Marie. It's good to know. If anybody else has suggestions, let me know, because I can burn through the entire 1 through 10 one more time. And that's great. That'll be enough content to keep us going every day until the big day. And we'll do a longer one maybe this Friday or something. Okay, my friends, here we go. We are going to start in 3, 2, 1. Let's do it. All right. So y equals kx, where k is a constant, y equals 8. Okay, so this is a directly proportional equation, y equals kx. So we know that y is 8 when x is 32. So what is k? It is, of course, 1/4, because 1/4 of 32 is 8. So we have a new equation, y equals 1/4 of x. That's usually what you want to do with direct variation. So then we want the value of y when x is 40. So plug and chug, y equals 1/4 of 40. Boom, 1/4 of 40 is, of course, 10. Done. Next. A group of friends ran a 200-meter race. The graph at the left and shows the Ryan's distance, R's distance, okay, blah, blah, blah. So they're all different things. T seconds since start of the race. Who stopped running temporarily before the race was over? That'd be the person who flatlines. So this looks like the distance is not changing from this portion, and that is G. Grace stopped running temporarily. Boom, done. Next, a clothing warehouse houses about 14,000 garments from the beginning of each year. Throughout the year, a small percentage of the 14,000. Throughout the year, a small percentage of the garments become lost or damaged and must be replaced. Each year, about 1.5% become damaged and about 0.6% become lost. Okay, so this is damaged, not lost, and this is lost. About how many garments must be replaced each year? Got it. Okay, so this is a straight calculator question. So due to loss or damage, I'm going to add them together and make it 2.1, which as a decimal is 0.021, and we need to take that of the 14,000. So of meaning multiply by 14,000. 294 is the winner, and it says about how many, so we can feel good about that approximation of 290. Next, in the equation of a b is a constant for which value b has no solutions. So it's very important. When we say no solutions, what we want is we want the variables to match up and the constants to differ. The constants already differ as 10 and 2, but I need it to be 7x on both sides, which means that b needs to be 3, because 3x plus 4x is 7x. A is the winner. Done. Number 5. Elena's dry cleaning garments every month. Above equation gives Elena's monthly profit in dollars. Okay, what is the meaning of 1250? So this is understanding the values in the equation. So I'm looking at this and I'm like, I can kind of, what is this? Is this profit? Elena's monthly profit. Got it. So what this tells me is in order to break even, she's got to sell 1,250. Because think about it. If it's less than 1,250, I'm clocking a negative profit, meaning I'm losing money. Because if it was like 1,000, it'd be negative 250 times that. At 1,250, she's breaking even. At 1,251, she's making a profit of 320. So this is out. Cleaning 1,200. Nope, that's out because we already know at 1,250 she breaks even. Yep, that's exactly what we said, break even. Now, look, another thing is, your first instinct might be to read something like this and then look at the answer choices. You see, I don't do that. I imagine the answer and I problem solve first, and I find that works a lot better for me and a lot of students. Of course, it may not always work best for you, so try different strategies. Here we go. Which of the following equations gives n in terms of L and m? Guess what? Isolating quantities question, amazing. So all we got to do is isolate n like they did here. So first I'm going to subtract 125 over m. Boom. Oops. L minus 125 over m was 50n. Then we divide everything by 50. So, and that's a L. So I divide both sides by 50 and we get L over 50 minus 125 over 50m equals n. And we can reduce that, divide top and bottom by 25, right? So that's 5 and that's 2. So it's L over 50 minus 5 over 2m for the win. L over 50 minus this one. C. L over 50 minus 5 over 2m. Yeah, I'm pretty confident. Let's roll with it. Boom, done. Number 7. Jonas is traveling to visit a friend 300 miles away. The friend has asked Jonas to call at least 30 minutes before arriving so he can pick up Jonas. So travels at a constant speed of 45 miles per hour. Which inequality shows the number of travel hours before? Call at least 30 minutes. Okay, so check it out. I'm going to kind of go through this process. So he needs to call at least 30 minutes. So, let's see. Distance. Hold on, give me a second to like work this out in my mind. Distance equals rate times time. So it's 300 equals a rate of 45 times time, right? So the amount of time it's going to take to travel, I'm going to divide by 45, is 6 2/3, okay? So it's going to take, which is 6 hours and 40 minutes. So that means you can call, so shows the number of travel hours for which, hold on, let me just think about this for a second. The number of travel hours. So the travel hours, so they're saying the travel, you got to call at least 30 minutes. So the travel hours before which Jonas should call his friend. So the travel hours should be less than or equal to 6 1/6 because, sorry, 6 1. Oh, wait a minute. That's 6 2/3. So it should be 6 1/3, not 1/6, right? Because 2/3 of an hour is 40. I'm sorry. 6 2/3 is the total, but then you minus a half. Oh yeah, I'm not minusing a half correctly. 2/3, excuse me, minus 1/2. That is 3/6 and 4. Yeah, it is 1/6. So it's 1/6. Let me explain what I just did there. So the total travel time is 640, like I said, or 6 2/3. And then we have to minus 30 minutes because we'd call at least 30 minutes before then. So 6 hours and 10 minutes. 10 is 1/6 of 60, right? 10 over 60 is 1/6. So they need to call less than or equal to 6 1/6 hours. Hold on one second. Okay. So check this out. Boom. Boom. Next. All right. In the figure at the left, TR has length 12. TR is length 12. Given sine of R. Wait a minute. R is a right angle. Oh, this guy, little r. Got it. Given that sine of R is 0.927, cosine of R that's adjacent over hypotenuse, and tangent of R, that's opposite over adjacent, which is the line is closest to the length of RS. So we're trying to find RS. So it's this. I know this is 12. Oh, these are both R. Interesting. What's the best way to do this? So R. Oh, I know what we do. Look, check this out. This is a hard question. I'm gonna do sine of R, which is, okay, so check this out. Sine of R equals opposite, which is 12, over the hypotenuse, which is, let's call this Y. And I like that because it's also part of the bigger triangle. So I can find what y is pretty quickly, right? Because it said that sine of r is 0.927. So check it out. 0.927 equals 12 over y. Multiply the y and divide by 0.927. So 12 divided by 0.927 is my y value. So y equals, so this value up here is 12.94. I'll just round to 100. Then we got to find x. So now I'm going to use tangent of r because it's opposite over adjacent, right? So check it out. Tangent of r, which is 2.472, equals, but again, tangent of r equals x over my y value, which I know is 12.94. And now I just multiply both sides by 12.94. So this times 32. Oh, it's 32 on the dot. Amazing. Okay, done. Number 9. Percentage of the population supplied. There was a lot of steps in there. I think I did it right, though, so we're just going to roll with it. Percentage of population supplied by water supply industry. A census was taken in 11 African countries. For each country, the amount in the population that had access to water from the water supply industry was computed and recorded to the nearest 5%. This amount was expressed as a percentage of total population. Wait, according to the dot plot, what is the range of these percentages? Hold on. I mean, it should be 70, because here's why. It's from the lowest to the highest. I'm going to read it one more time. A census was taken in African countries. For each country, the amount of the population that had access to water from the water supply industry was computed and recorded to the nearest 5%. This amount was expressed as a percentage total population. According to the dot plot, what is the range of these percentages? So range is the greatest minus the smallest. 100 minus 30. I mean, they said to the nearest 5%, but I think we just have to roll with these numbers that they're given. So that's it. Last but not least, how many distinct real solutions of the equation above have? I'm going to tell you it's 0. I'm going to tell you why now. So it's a squared plus 1 equals 0. So I'm going to explain this 2 different ways. Number 1, to get this to be 0, this has to be -1, right? Because that's the only thing that adds to 0, that adds to 1, that zeroes it out. Well, guess what? You can't square a number and get a negative number. So there is no real solution. This is dunzos, right? The other way you can figure this out is you just isolate. Subtract 1 from both sides. A squared equals -1. Once again, we can't get an answer to this. If you tried to, you could square root it, and you get a equals the square root of -1, which we do have a term for, which is I, but that's an imaginary. This is saying how many real solutions. This is not real. 0 for the win. Now, normally you'd use the time to go back and check your work. I'm just going to roll with it. I think I got everything right. Let's hope I did. Boom. All right. So that is excellent. We're good to go. I'm going to see if we got any questions, and then I got to dip in a second. So that's amazing to hear that. Rorona Zorro, 570 to a 710. Incredible. What do you recommend for March SAT? I mean, that's a broad question. You got to give me some more information. Oh, Turkey. What's it called? Günaydın. Oh, I don't know what time it is there. But merhaba. And Umar Shaikh, hello, what's up? You're from India and completed my 12th, want to study abroad. Please guide. I mean, you got to ask, this is what I'm here for, to help you guys with your SAT stuff, right? So I'm around. Do you know what Alex is? Yeah, I do know what Alex is. Alex is an amazing math program. Do I think it's a good application for SAT prep? Not so much, but in general, for learning math, it's an amazing application. And I use it with a lot of my students who want to do extracurricular. Plus, a lot of schools use it as well. Don't be scared, Augustine. Just keep with me, keep with the channel, and keep prepping and keep practicing. That's it. By the way, if you guys haven't checked out our SAT video course, it's in the description link below. You can check it out. You can subscribe month to month. It's $30 a month. It's awesome. We got 4 practice tests up there. I'm going to try and get some more up there before the March SAT, so you guys have as much material as possible. But the main thing is we're going to be doing streams every day until the SATs coming up. So let me know what you want to see, and that's it. We're going to make it work. All right, guys, that's it for today. Tomorrow we'll be back. We're going to eventually release a schedule and let you know what's going down, and I wish you all the best of luck. Thank you guys so much for joining, and if you want to see more, make sure to subscribe. And if you did like the video, click that like button, and I will see you in the next video. Take it easy.